Another day, another story. Aditya L1, from Sanskrit, Aditya, sun, is a coronography spacecraft to study the solar atmosphere, designed and developed by the Indian Space Research Organisation, ISRO, and various other Indian research institutes. It will be inserted at about 1.5 million kilometers from Earth in a halo orbit around the L1 Lagrange point between the Earth and the Sun, where it will study the solar atmosphere, solar magnetic storms, and their impact on the environment around the Earth. It is the first Indian mission dedicated to observing the Sun. Welcome to Tabo Eminent Channel. Nigar Shahji is the project's director. It was launched aboard a PSLV-XL launch vehicle at 11:50 IST on the 2nd of September 2023, 10 days after the successful landing of ISRO's moon mission, Chandrayaan-3. It successfully achieved its intended orbit nearly an hour later, and separated from the fourth stage at 12:57 IST. Aditya L1 is India's first dedicated mission to study the Sun. The primary goal of the mission is to gain a better understanding of the Sun's outermost layer, the solar corona, and the impact of solar activities on the Earth's climate and space environment. Solar wind monitoring. The mission intends to monitor the solar wind, a stream of charged particles emanating from the Sun. These particles can affect Earth's space environment and can cause space weather phenomena, which can impact communication, navigation, and power grids. Magnetic field measurements. Aditya L1 will also measure the magnetic field of the Sun, which plays a significant role in various solar activities such as solar flares and coronal mass ejections. These solar events can have significant effects on Earth's magnetosphere and ionosphere. Understanding solar variability. By studying the Sun's behavior over an extended period, the mission aims to contribute to a better understanding of solar variability and its impact on climate and space weather. Mission instruments. The Aditya L1 mission was expected to carry a suite of instruments to achieve its scientific objectives. Some of the proposed instruments included Visible Emission Line Coronagraph, VELC. This instrument would observe the visible and ultraviolet emissions from the solar corona. Solar Ultraviolet Imaging Telescope, SUT would capture images of the Sun in the ultraviolet range. Solar Low Energy X-ray Spectrometer, SOLEXes. This instrument was designed to measure low-energy X-rays emitted by the Sun. Mission objectives. Aditya L1's main science objectives are observations of the dynamics of the Sun's chromosphere and corona, studies of chromospheric and coronal heating, the physics of partially ionized plasma, of coronal mass ejections, CMEs, and their origins, of the coronal magnetic field and heat transfer mechanisms, and flare exchanges. Observation of the physical particle environment around its position. Determination of the sequence of processes in multiple layers below the corona that lead to solar eruptions. Drivers for space weather, and the origin, composition and dynamics of solar wind. Studying the solar corona. Aditya L1 aims to observe the Sun's outermost layer, the corona, which is much hotter than the Sun's surface. Understanding the behavior and dynamics of the corona is crucial for unraveling mysteries about the Sun's atmosphere. History. Aditya was conceptualized in January 2008 by the Advisory Committee for Space Sciences, ADCOS. It was initially envisaged as a small 400 kilograms, 880 pounds, LEO, 800 kilometers, satellite with a coronagraph to study the solar corona. An experimental budget of 3 crore rupees was allocated for the financial year 2016-2017. The scope of the mission has since been expanded and it is now planned to be a comprehensive solar and space environment observatory to be placed at Lagrange Point L1, so the mission was renamed Aditya L1. As of July 2019, the mission has an allocated cost of 378 crore rupees excluding launch costs. Payloads. The instruments of Aditya L1 are tuned to observe the solar atmosphere, mainly the chromosphere and corona. In situ instruments will observe the local environment at L1. There are 7 payloads on board, with 4 for remote sensing of the Sun and 3 for in situ observation. The payloads have been developed by different laboratories in the country with the close collaboration of various centers of ISRO. Name. Aditya is named after Surya and the Adityas, the revered Hindu deities representing the Sun. The L1 designation denotes Lagrange Point 1, signifying the precise location situated between the Sun and Earth where the Indian spacecraft is set to embark. Overview. Lagrange points in the Sun-Earth system, not to scale, A small object at any one of the 5 points will hold its relative position. The Aditya L1 mission will take around 109 Earth days after launch to reach the halo orbit around the L1 point, which is about 1,500,000 kilometers, 930,000 miles, from Earth. The spacecraft will remain in the halo orbit for its planned mission duration while maintained at a station-keeping cost of 0.2 to 4 meters per second per year. The 1,500 kilograms, 3,300 lb, satellite carries 7 science payloads with diverse objectives, including but not limited to coronal heating, solar wind acceleration, coronal magnetometry, origin and monitoring of near-UV solar radiation, which drives Earth's upper atmospheric dynamics and global climate, coupling of the solar photosphere to chromosphere and corona, in situ characterizations of the space environment around Earth by measuring energetic particle fluxes and magnetic fields of the solar wind and solar magnetic storms that have adverse effects on space and ground-based technologies. Aditya L1 will be able to provide observations of Sun's photosphere, chromosphere and corona. In addition, an instrument will study the solar energetic particles flux reaching the L1 orbit, while a magnetometer payload will measure the variation in magnetic field strength at the halo orbit around L1. These payloads have to be placed outside the interference from the Earth's magnetic field and hence could not have been useful in the low Earth orbit as proposed on the original Aditya mission concept. One of the major unsolved issues in the field of solar physics is that the upper atmosphere of the Sun is 1 million K, 1 million degrees Celsius, 1,800,000 degrees Fahrenheit, hot, whereas the lower atmosphere is just 6,000 K, 5,730 degrees Celsius, 10,340 degrees Fahrenheit. In addition, it is not understood how exactly the Sun's radiation affects the dynamics of the Earth's atmosphere on shorter as well as on longer time scale. The mission will obtain near-simultaneous images of the different layers of the Sun's atmosphere, which will reveal the ways in which energy may be channeled and transferred from one layer to another. Thus, the Aditya L1 mission will enable a comprehensive understanding of the dynamical processes of the Sun and address some of the outstanding problems in solar physics and heliophysics. Launch. Flight sequence of PSLV C-57. On September 2, 2023, at 11:50 IST, the Polar Satellite Launch Vehicle, PSLV C-57, accomplished the successful launch of the Aditya L1 from the second launch pad of the Satish Dhawan Space Center, SDSC, located in Sriharikota. The Aditya L1, following a flight duration of 63 minutes and 20 seconds, achieved a successful injection into an elliptical orbit around the Earth at 12:54 IST. The Aditya L1 is scheduled to undergo a series of 4 Earth-bound orbital maneuvers prior to its placement in the transfer orbit towards the Lagrange point L1. Aditya L1 is projected to reach its designated orbit at the L1 point approximately 127 days following its launch. 1. Significance and potential discoveries. The Aditya L1 mission holds the promise of significantly advancing our understanding of the Sun's behavior and its interactions with Earth and the space environment. The planned observations and data collection from this mission could lead to several groundbreaking discoveries and insights in the field of solar and heliophysics. Coronal heating mechanism. One of the central puzzles in solar physics is the coronal heating problem, why the Sun's corona is much hotter than its surface. Aditya L1's instruments, particularly the Solar Ultraviolet Imaging Telescope, SUT, and the Visible Emission Line Coronagraph, VELC, will enable detailed studies of the corona's dynamics and composition. By closely examining the behavior of the corona, scientists hope to unravel the mechanisms responsible for heating this outer layer of the Sun. 2. Space weather prediction. Understanding the Sun's behavior is crucial for predicting space weather events, which can have significant impacts on Earth's technology and infrastructure. The mission's data will provide insights into the processes that lead to solar flares, coronal mass ejections, CMEs, and solar energetic particle, SEP, events. These insights can contribute to more accurate forecasting of space weather phenomena and their potential effects on communication systems, satellites, and power grids. 3. Solar wind and magnetic field studies. Aditya L1's instruments like the Aditya Solar Wind Particle Experiment, ASPECS, and the magnetometer, will offer a comprehensive view of solar wind's properties and the interplanetary magnetic field. This data will help refine models of solar wind's behavior and its interaction with Earth's magnetosphere, shedding light on the dynamics of this critical space environment. 4. Understanding Earth's climate. The Sun's activity can influence Earth's climate over long timescales. Aditya L1's observations of near UV solar radiation and its impact on Earth's upper atmosphere can contribute to understanding how solar variability might affect Earth's climate patterns. This could provide valuable information for climate researchers seeking to differentiate between natural and anthropogenic factors driving climate change. 5. Comprehensive solar atmosphere imaging. The suite of instruments on Aditya L1 will provide multi-wavelength observations of the Sun's atmosphere, from the photosphere to the corona. These simultaneous observations will allow scientists to trace the flow of energy and matter between different layers, offering insights into the complex processes that govern the Sun's behavior. 6. Origin and dynamics of CMEs. Coronal mass ejections are powerful and potentially disruptive solar events. Aditya L1's observations of the initiation and evolution of CMEs will contribute to our understanding of their origins and behavior, potentially leading to improved models for predicting their occurrence and effects. Orbit-raising burns. On the 3rd of September 2023, the Aditya L1 performed its first Earth-bound maneuver, raising its orbit from a 245 kilometers (152 miles) orbit to a 22,459 kilometers (13,955 miles) orbit. Thanks for watching. Request you to subscribe the channel.